Hello, Math 10C. So we continue our journey with multiplying polynomials with lesson 3, multiplying two binomials. What do those words mean? Well, if you remember last time we multiplied a monomial by a polynomial. So for example, last day in lesson 2, you might have multiplied 3x times an x plus 3, and then you might have even had subtract a 2x times x minus 2. But in both of these cases, you were multiplying a monomial times a binomial or other bigger polynomials. And so all you had to use was the distributive property, and you'd multiply it out. And remember that that is a minus 2, so you'd multiply out by minus 2. So what's the difference about lesson 3? What are we building? Well, we're building a new product, and we need to have a strategy to deal with this. The product of two binomials, or maybe even more. So instead of having one thing, a monomial times a binomial, which would create two arrows, what would you do in another monomial and distribute? What would you do with a question that has two things times two things? So for example, what would you do if you had 2x minus 5 times another two things like 3x plus 7? What would you do with that? So in this case, let's look at the first question. What does x plus 3 times x plus 2 look like when you build it with algebra tiles? Well, if you build that product with algebra tiles, I want you to try and fill it in and then come back and look and see if Mr. K got it right. So they're all positive. You've come back, and what you should have is that I've got in the diagram, that product turns out to be x squared plus 5x plus 6. So doing it with algebra tiles is fairly straightforward. If we look at this question, well, what is the question? Well, clearly, if I scroll down a little bit, I can see that this question is really about x. The top one is x 1, 2, 3, 4 plus 4, and the bottom one is 2x, or the one going down on the side is 2x's plus 1. Well, if we multiply that out with algebra tiles, what do we get? What do we get? We get, by the looks of it, we get 2x squareds. Count them all up. We get 1, 2, 3, 4, 5, 6, 7, 8, 9 x's, and 2x squared plus 9x's plus 4. So we can multiply binomials times binomials with algebra tiles, but the challenge with this, and I'm not going to do C and D, you can see if you want to do those, you can, but it does become quite challenging if you try and do questions like this with variables other than just plain x. So the algebra tiles aren't going to work for all of them, but it's the first way we can see how these work. So what's another method that we could use? Well, if you look ahead in the next slide, we talk about using a diagram. What if we use a diagram? Oopsie, it's not working. So in the diagram method, if you took I believe it's the same question as we did in the first one, x plus 3, x plus 2, how could you do that? We already know the answer is x squared plus 5x plus 6, but if you look at it from a diagram perspective and you just use your exponent laws and you set up a diagram and say, well, this is really x and a plus 3 times x and a plus 2, and now you just set up the area to be x squared, 3x, 2x, and simply by using products for each one of these boxes, right? So for example, if we look and say, well, what would 5x minus 6 be equal to? 5x and a minus 6, and then I multiply by a 2x and a plus 1. So you set up your diagram around that situation, and now 5x times 2x, I'll change the color, that's going to be 10x squared. 2x and minus 6 is minus 12x. This box is a positive 5x. And lastly, this box, positive 1 and minus 6, gives you minus 6. Therefore, the answer to your question, and look at how cool this is. I've got my x squareds. These two are like terms, so they collect together. And my answer for this question is 10x squared, 10x squared minus 7x and minus 6. Minus 7x and minus 6, and all was good. So we could have done that one with algebra tiles. We already We've already done that several times, but it gets really tricky when you do something like this because trying to do a question like this with algebra tiles becomes pretty tricky. So if you look at question C, I say, well, okay, I've got 3p plus 2q, and then on the side I've got p and 9q. So we make up our chart. That's great. And now we have to do our product. So this is a 3p squared. This is 6p and q. This is 27p q. And lastly, this is 18q squared. Final answer, we collect our like terms, and you can see the diagram, you can see the PQs are always diagonally, like terms are diagonal. So final answer, what's the question's answer? 3p squareds. 27 plus 6 is plus 33pq. And lastly, you've got 18q squared. There is your trinomial that that's equal to, right? Now, just out of interest, area can be used for doing weird products too. It's not necessarily what we would do, but if somebody said for you, hey, by the way, try and do 32 times 24 and use long multiplication. That's one way to do it, but you might have done this in junior high or elementary. You could also just say, well, I'll multiply 30 and 2 and 30 and 4, and then I think we can all do 30 times 30 is 900, 2 times 60 is, sorry, 2 times 30 is 60, 4 times 30 is 120, and 2 times 4 is 8. And if you add up those numbers, it's kind of a nice way to do long multiplication, just a different way of doing it in your head, right? We're going to use it for algebra. So is there a better way than using diagram? And again, you don't have to use all these methods. You need to find the one that works best for you, right? So what's another method of multiplying binomials together? Well, we already actually know it. So I just want to erase this, okay? So we've already done something called the distributive property, and now we just need to do it more than once. So in other words, I need to do 4 separate products. I asked you last day, and if I said to you, and I'm just going to cover up this 3 for right now, if I said to you, which one of these terms is being multiplied by this x? You would say, oh, Mr. K, that's easy. Both of them are. I need to multiply this x to this x, and I need to multiply that x by 2. But that's if this was a monomial. I can't just pretend that that other term didn't exist. So I need to go back and say, oh, there was actually a 3 there. So now if you ignore the x and you say, oh, well, let's pretend the x wasn't there, which one of those terms is that 3 multiplying to? And you'd say, well, that 3's got to go to the x, and that 3's got to go to the 2. So in other words, when you're doing binomials, you just have to use the distributive property twice. And if you use the distributive property twice, you end up with the entire product. So if you look at this, I think we can kind of ignore that part if you want, because all you really need to do is say, look at the A first and say, who do I need to give the A to? Who do I multiply to? Well, you got to go A to C, and you got to go A to D. But you got to go B to C and B to D. Why? Because each of these needs to be multiplied to both of those. So you end up with 4 terms, AC, AD, BC, BD. And that's what we need to do here. So using the distributive property, I'm just going to use red arrows and green arrows. This is multiplication. I got 2 things times 2 things, right? So what do? This x has got to go to both. Nice. This 3's got to go to both. Done. I need to make those products. 4 products need to happen. So what does it make? Well, the first 2 arrows are x squared plus 2x. The next 2 arrows are plus 3x plus 6. And so when I collect these terms together, I get x squared plus 5x plus 6. And all is good in the land, right? So if we look at some of the other questions that we can get here, I'm going to skip around. If I do the same thing here, binomial, binomial. 1, 2, 3, 4. I do those products. X times x, first 2, x squared. X times minus 5y, minus 5. I like to keep it alphabetical. Minus 5xy. The second 2 were plus 4xy and minus 20y squared. Final answer, an x squared minus 1xy, you don't really need the 1, and a minus 20y squared. And that's as good as it gets. And the trickiest ones would be something where, yeah, I got all these ugly ones. Oh, bigger exponents, bigger variables. Same thing, 2 things times 2 things. 1, 2, 3, 4. 2 things times 2 things gives me 4 products. So I write them all out. I color code them. 9 times 5 is 45. How many A's? Whoopsie, A to the 5. And positive 54A squared. The blue ones, minus 1 times 5, minus 5A cubed, and a minus 6. And there aren't any terms that are like that I can add up. But I'll bet you the answer in the book would probably put it in descending order. So it would have 45A to the 5 minus 5A cubed, because that's a higher degree, plus 54A squared minus 6. Okay? So that's really all the methods you need. There's one last method that is basically the distributive property, but somebody gave it a name, and they gave a name to all the arrows. So in the distributive property, they call my first 2 red arrows, they call first and outside. Why? Because that's the first arrow and that's the outside arrow. So you call that first, and this one would be outside. And then on the other arrows, they call this one the inside arrow, and this one they call the last arrow. So by doing FOIL, it's just a fancy way to complete the distributive property. It doesn't matter which method you use in completing this. The only thing you need to remember is that you need to get the right answer, because close doesn't count in this. You need to have it right in order to solve algebraic problems. So if you look at 5a, x squared plus 4x plus 6x plus 24. The only question that you'll see in here is you'll notice that we'll maybe talk about this in class. Having a squared means that you still have to FOIL it. Having a squared means that I will expand out when I have a squared. That's what I'm saying here. I will expand out when I have a squared. In other words, 6a minus 5b squared means you got 2 of them. 6a minus 5b times 6a minus 5b. And you need to get a trinomial when you have that. The answer, I'm going to put a big sad face, no. The answer is not 36a squared minus 25b squared, or positive 25. Not correct. That is a highly wrong conceptual error. You can't just square these two. There is no rule for exponents for addition and subtraction. So that's really illegal. You have to do it the way I said there. And you'll see in your assignment that you'll stub your toe if you do that wrong. Okay? Have a good assignment, and we'll see you tomorrow.